high-rise building, the axial deformation for column cannot be ignored, and special consideration is required for the construction and design. Today we will cover the construction stage analysis for the column shortening. It will be helpful for the engineers to understand the basic concept of the construction stage analysis, and also we can see how Midas consider the construction stage analysis with creep and shrinkage effect. Before we go to the details of the construction stage features, I would like to introduce Midas Gen briefly because some of you are very first time for the Gen. So I will show you the major features of Gen. First of all, it shows the strong point of Midas Gen. First of all, the seismic specific functionality is one of the strong points. We can easily specify the seismic load for the static seismic load as well as response spectrum load. Linear and nonlinear time history load can be defined, and base isolator and dampers. And also we can perform the pushover analysis and fiber analysis. Recently we have been implemented capacity design as per the Eurocode 8 and NTC. And comprehensive design codes are another strong point in Gen. The international building codes are implemented for the American standard, European, British, Indian, Canadian, so on for the RC structure, steel, SRC, footing, and slab and wall design, as well as capacity design. And the other one is highlight specific functionality that we will see today. 3D column shortening reflecting the changes in modulus of elasticity, creep, and shrinkage are available. And we can activate and deactivate the geometry, support, and loading during the construction stage. During this stage, we can fully consider the time-dependent material. That is the difference between another software, FEM softwares. Even though we are considering the high-end analysis, but most important thing in Gen is ease to use. We provide the intuitive user interface such as worktree, task pane, and also modeling is very easy. We provide built-in section property calculator, and also for the BIM, we provide the Tekla structure and Levy structure data transfer. Let's see the introduction of column shortening. Why construction stage analysis is required? There would be major two reasons. First one is live load, wind, and seismic loads are applied at once to the entire complete structure. However, in case of the dead load, it is the type of the sequential loading as shown in this slide. So, since most buildings are constructed by one story or several floor units at once, so we need to consider the construction sequence in analysis. This graph shows how much the difference when we consider the construction stage analysis and simple conventional analysis. This is the 40-story building, and this column shortening, this column's negative moment is displayed here. So line in blue represents the conventional analysis. So the difference is increased as the floors goes up, and at the top floor, almost 40% of the negative moment are different. The other reason why construction stage analysis is required is compensation for the differential column shortening in high-rise building. There are 4 reasons which occur column shortening. Firstly, the elastic stresses due to the gravity load and creep caused by gravity load, drying, shrinkage, and temperature variation. This table shows the typical comparative shortenings of 80-story steel and concrete building. due to the high stresses, the elastic shortening of the steel column is higher than the concrete. But in the concrete building, we can see the creep and shrinkage shortening is quite high. So we cannot ignore those effects during the analysis. Effect of column shortening can be divided into two things. First one is non-structural effect. The other one is structural effect. For the non-structural effect, the total amount of the shortening has been effect on the such non-structural elements as pipes and elevator rail attaches to the concrete. Also, cladding details are affected by overall changes in column length. For the structural effects are caused by different movements only, so not by the total movement. Slab and beams will be distorted and gravity load redistribution will occur. As you can see in this picture, the slab movement causes the load transfer to the column that shorten less from the column that shorten more. So load redistribution will occur. In order to prevent that differential shortening, we need to take into account the compensation. For the shortening, there are two different types of the shortening. First one is pre-slab installation shortening. The other one is post-slab installation shortening. Pre-slab installation shortening is the shortening before casting the slabs. And post-slab installation shortening is after casting the slabs. So we can see the line 2 represents the design level. Due to the shortening of pre-slab installation and post-slab installation, the differential shortening would occur. So when we construct this type of building, we need to consider the compensation. So we will install these beams as the number 1 line. Actually, the amount of the compensation is different for the RC structure and steel structure. In case of RC structure, the amount of shortening before slab installation is no importance because the compensation is usually considered when casting slab by leveling the forms. So, therefore, the post-slab shortening due to the subsequent loads and creep shrinkage is to be compensated. However, in case of the steel structure, steel column is fabricated to exact length, and they have the attachment to receive each floor's slab. So we need to consider both pre-slab installation and post-slab installation shortening. This slide shows the procedure how to apply the column shortening. Firstly, we may perform the pre-analysis for the column shortening. Here we consider the material and section property and load and construction sequence. After that, we will consider the load redistribution, then we will perform the analysis. And we also have the experiments for the material, compressive strength, modulus of elasticity, and creep shrinkage. So by reflecting those material property, we will perform the column shortening analysis. And then after the construction is started, also we will measure the shortening with the strain gauge. So based on these results, the strain gauge's shortening results, we will reflect it and update the column shortening, the length. So we will perform the column shortening analysis, and then this prediction will be applied to the field. So we have seen the general concept of the construction stage and column shortening. I would like to show you the project application which has been done using MidasGen for the column shortening analysis. First of all, the Burj Dubai, the Burj Khalifa. It has the 160 floors with the 700 height. The general contractor, Samsung Development, used MidasGen to calculate the column shortening and applied it to the real construction. In order to account the time-dependent concrete effect in the Burj Khalifa, a comprehensive construction sequence analysis considering creep and sweep effect was used to consider the time-dependent behavior. Let's see the model file. So this is the Burj Khalifa model file. For each construction stage, first of all, install the mat, and then we install the core walls first. After installing the core walls, then continuously we install the frames. So for each construction stage, so for this type of the auto climbing system can be also simulated using MidasGen. So finally, the model file has been so this is the final model file. Okay, the other project I would like to show you is the SKS Trenyu building in Korea. This building has the special shape as you can see in this picture. Its composite section, the composite structure, and 36-story building. So I will show you the model file. This is the whole model. And for the construction stage, firstly, install the basement core wall for each story, and then install the walls and frames of the first basement. And then with the top-down method, it has been modeled. After that, the first story will be installed. So final stage is finally installed, as you can see here. So top-down method also can be simulated using MidasGen. And if you look at the columns, the composite column has been used. So for the composite column, we can use the composite section for construction stage. For those type of the composite section, the steel will be installed first, and then in the next stage, concrete needs to be casted. So MidasGen can consider this construction sequence for the composite sections also. So if you look at the stage, firstly, the frame has been entered, the bare steel has been installed, and then the next stage, we can see the concrete has been casted for the first story section. So it's possible using MidasGen. Let's go back to the presentation. The other application is Hanoi Landmark Tower in Vietnam. It has been constructed by the Gyeongnam, and it has 40 floors, one high building, and 94 floors, two twin towers. Also for those buildings, MidasGen has been used for the column shortening. So we have seen the general concept and the project application. So I would like to show you the procedure, how we can define those data in MidasGen. This is the flow chart that we need to do using MidasGen. Firstly, we define the material and section and create the element, which is the same as general modeling. After that, for the construction stage, we need to define the group. So element group, boundary group, and load group should be defined. And then we define the time-dependent material. If we go to the corresponding page, the time-dependent material, we can consider those three: creep effect, and shrinkage effect, and the time-dependent compressive strength. Those can be assigned by the user-defined function, or we can use the database as well. Following codes are implemented in Gen: Eurocode and ACI, CBFIP, PCA, Indian time-dependent materials are available. As I mentioned just before, if we need to enter the experimental results that we checked, then we can use the user-defined time-dependent material as well. Go back to the chart again. And after we define the time-dependent material, then we enter the construction stage analysis data. In this data, we specify the duration of each stage, and also activate or deactivate each group for the element, boundary, or load. If we see the dialog box, this is the construction stage data dialog box. So for each tab, element, boundary, or load, we can activate or deactivate them. Also, we can specify its duration. And there is another function which is called additional step. Additional step can be used when there is no changes in the element and only loads needs to be activated or deactivated. In that case, without making new different stage, we can just simply add the additional step and then activate or deactivate the loads. After we enter all those required data, we can check those activation or deactivation results in the table format as well. So it would be very helpful to check those data at once. And I would like to explain another concept in MidasGen for the construction stage analysis. There are three different stages that MidasGen is considering. Firstly, the base stage. Base stage is a stage for the defining structure and boundary and load groups. So this base stage is not applied for the analysis, construction stage analysis. So it's only for the modeling. So only in the pre-processing we can see the base stage, and we can change any data from only in the base stage. And the other one is construction stage. Construction stage means each construction stage that we activate or deactivate each data, boundary, loads, and elements. And finally, the post-construction stage. Post-construction stage we can check it only after performing analysis. So this is stage for the performing analysis for transient loads such as wind or seismic loads. So after performing construction stage analysis, the other load like wind or seismic load will be applied based on the member force of the final stage. So those results are based on the post-construction stage. Go back to the chart again. After defining the construction stage data, then we perform an analysis. And then we check the results. For the results, we can check the results for each construction stage. So if you go to the corresponding page, we can check the member force or deformation for each different stages. And also we provide min-max stage, which means among all entire stages, program also provides the maximum or minimum values for the member force or deformation. And creep and shrinkage results can be separately checked as well. After checking these results, and then finally, we check the column shortening results. For the column shortening, by specifying the position of the column, then we can check post-slab installation shortening or pre-slab installation shortening, or the summation between two. So we will see this, how to check it during the demonstration. Then I would like to explain some other useful features for the construction stage analysis. First of all, MidasGen provides the building generation wizard for the construction stage. So using this wizard, by simply specifying the load case and storing incremental duration and member age, the program can automatically consider all the stages, and then the stage data will be generated. So for this, we will also check it during the demonstration. And the construction stage analysis for the composite member. As I mentioned just before, with the model file, the composite section can be defined for each different part. So by specifying it as the activated stage, then we can consider this in the construction stage analysis. Also, by specifying this composite section for construction stage data, we can consider the more accurate results for the concrete creep and shrinkage effects. And the auto-climbing formwork system. The construction stage for auto-climbing formwork system also can be generated as we have checked using post-by model. So in the real practical building, it's common that we model the core walls first and then install the other frames. So it can be defined using MidasGen. Material stiffness changes for the crack section. In order to consider the cracked section in the stages, we can also change the stiffness in this model. We can see the section stiffness scale factor has been entered. For the certain stage, if we want to consider the crack of the section, then by reducing the stiffness, we can consider them. So by assigning those data with the group, then group can be activated or deactivated during the construction sequence. So we can consider during the construction stage analysis. And plate offset function. Let me show you another model file. In this model, the plate element, plate wall has been installed here. It's common that the wall's thickness is different for the low parts of the building and high parts of the building. If I active only the plate element, you can see the changes of the thickness. So for the low part and medium part and the high part. So in this case, in the real structure, the outside of the building should be in the same plane. In order to consider that, we can enter the plate offset function. So by entering the plate offset, we can also consider the eccentricity due to the self-weight of each load, the plate element. So for the building, plate offset or beam end offset would be also useful for considering the real construction condition. And the other one, the springs. In order to consider the soil interaction, we can enter the various type of the spring, such as point spring support, or surface spring support, pile spring support, so on. For those springs, by assigning them as a group, then we can use them in the construction stage analysis as well. So in the building, if we want to model the piles or mat foundation, we can enter those springs and we can consider them during the construction stage analysis. And lastly, the tendon loads. If we look this model file, it has the tendon data at the transfer girder. You can see the tendons in the first story girder here. So for this, in order to enter the tendons, by specifying the required property, like we can select between the pre-tension, post-tension, or external tendon, and specify the material type, and enter the area of the tendon and some other data. And then we need to specify the position of the tendon. After entering those data, we can simply enter the pre-stress load to the beam element. And after performing the analysis for the tendons, we can check the tendon primary and secondary forces. I performed the analysis previously, so I will show you the results for the tendon primary and secondary. We can check the results for the dead load or live load, tendon primary, secondary, and creep shrinkage. First of all, the tendon primary. Firstly, specify the stage. Then we can see for each different stage, we can check the tendon primary force. Tendon secondary is the same. For each different stage, we can check the tendon secondary forces in the model view as well as in the table format as well. So by selecting it and select the desired stage, and then we can check the results here. Those results can be also exported to Microsoft Excel as well by right-clicking and export to Excel. For the tendons, loss data is important. MidasGen also provides the tendon loss graph. Specify the tendon, and then by changing the stages, we can check the tendon losses for each tendons. And this data can be saved in as an image or text format as well. So we can consider the tendons in the beam element. Then I just explained the desired steps and useful features for the construction stage analysis. Then I would like to show you which data we need to enter and how we can do with the MidasGen. Before we go to the program, let's see the example model in details. This is the 12-story building. In the RC structure, you can see the section size and materials. This shows the construction schedule. For the construction schedule, first day, the formwork of the first floors will be installed. And after 2 days, which is third day, we cast the concrete. And 5 days after, second floor's formwork will be installed. 2 days after, again, the second floor slab will be casted, concrete will be casted. So as you can see, it has the 5 days for the concrete casting, 2 days for the 5 days for the formwork installation, 2 days for the casting. So this 7 days term is repeated for further dates. Same, 2 days after casting, 5 days after install the next floor's forms. Especially in the 22nd day, we remove the formwork of the first floor. As we just checked, the concrete has been casted in the third day, and the formwork has been removed in the 22nd day, which means the active age of the member is 19 days to activate this member. And then other terms are same. So we can see in the table to check the construction schedule. This part in orange represents how we enter those data in MidasGen. This represents each day First day, formwork installation for the first floor. Third day, concrete casting, and so on. Then 22nd day, as we have checked, we have activate the first story slab. So it will be the first stage. And the member age would be the 19 day. We just checked. And the stage duration is the 7 day, which means the concrete casting 2 days and 5 days for the formwork installation of next floor that we just checked in this cycle. So this will be repeated for each different floor. And mostly the end part of this construction, after removing the 11 floors formworks, and then we enter the superimposed dead load. Superimposed dead load is entered for 3 floors at once. So 1 to 3rd floor, and then 4 to 6th floor. It has the 3 different datum. So superimposed dead load is entered, which is the 71 day in the program. And then live load will be also entered, which will be the 112 day in the program. So let's enter those data in MidasGen. For this, I will start from this model file. First of all, we can simply enter the time-dependent material data. As I mentioned, MidasGen provides the various database for the time-dependent material. Go to the property, time-dependent material, and firstly, let's enter the creep and shrinkage. As we have seen during the presentation, CBFIP, ACIPCA, and Indian, European, and user-defined are provided. I will use the CBFIP for the gutters. Enter the strength of the concrete and notational size. The notational size will be different for each different member, so we will select the auto calculation by the program. So at the moment, I will enter number 1 and enter the age of the concrete. By clicking the Show Results button, we can check the creep coefficient graphs. Apply, and also for columns. Enter the strength, other data same. Apply, and also for walls. The same strength. Okay. So we has been entered for the creep and shrinkage data. For the modulus of elasticity, also go to the property and compressive strength. Click Add. And then also similarly specify the code CBFIP and enter the strength. By clicking redraw the graph, we can check with the time domain, the changes of the compressive strength. Okay. Also for the columns, column and walls. Okay. And then we need to make the link between the time-dependent material and the previous material we have been entered. For this, go to the model, property again, and time-dependent material link. By selecting for creep shrinkage and compressive strength, and select the material to make the link. By clicking it, it has been entered. Similarly for column, and for wall. Okay. Just before, when we enter the clip and shrinkage and compressive strength data, it was in blue color. But by making the link between the previous material, we can see the color has been changed in black, which means it has been assigned to a certain element. After entering this time-dependent material data, for the notational size of the member, as I mentioned earlier, we will use the program auto-calculation. For this, go to the Change Element Dependent Material property. As per the CBFIP that we used, for all the elements, we will use the auto-calculation for the notational size. So it would be very complex if we do not use the auto-calculation. So using MidasGen, we can simply consider those notational sizes for each different member. After that, now we will enter the construction stage data. Using the wizard, go to the Load, Construction Stage Analysis Data, and Construction Stage Wizard. From this dialog box, go to the Automatic Generation. Firstly, for the dead load, which is the self-weight, as we have checked in the presentation, story incremental will be 1. One by one story will be increased, and the duration of each story is 7 days, as we have checked, 2 days for the casting concrete and 5 days for the installation of the further floor. And member age that until we remove the formwork, it takes the 19 days. And superimposed dead load, also we can consider it. As we've seen, it will be increased 3 floors as 1 unit. So story incremental will be 3, and starting day will be 71, and day incremental will be 3 days. As we've checked, it has 3 day term to enter the next one's self-weight, the superimposed dead load. And also we can consider the live load. Live load is applied to all the stories at once. So story increment will be 12, and start day will be this one that we have checked in the presentation. And the day incremental, since this data, this live load will be entered at once, so there will be no further data. So any number would be fine except 0. So I just entered the 1. Then we can see the data has been entered in this table. By clicking OK, the worktree, we can check the data, and with the model view, we can check these changes as well. From the first stage, with the story incremental, this can be checked. If we clicking this button, Define Concrete Stage, or go to Load, Construction Stage Analysis Data, and Define Construction Stage, we can see each different stage, which load, which element, and boundary condition and load has been activated or deactivated with each different duration. In this data, we will enter another stage to consider the creep and shrinkage effect, which is the 2 years after. Enter the date. And there will be no new activation for the element, boundary condition, or load. So just clicking OK. Then it's done. I will also show you some other analysis option for the construction stage analysis. In order to reduce the analysis time, if we need to perform analysis only up to the specific stage, by selecting it, we can reduce the analysis time. So in this case, we can use it. And for the cable element, we can consider the nonlinear analysis in the construction stage analysis. And time-dependent effect we will consider. And another thing, if we have entered the live load during the definition of the construction sequence, if we want to check the results for the live load separately, by selecting it and clicking as Add, it will be distinguished from the dead load, because those loads we entered during the construction stage those results will be displayed as a dead load. So total amount will be checked. But if we want to make some load case distinguished from dead load, then we can use this option. Clip shrinkage effect we will consider. Okay. So we have entered all the required data. In order to reduce the analysis time, I will open the model file that I previously performed the analysis. This model is exactly the same model that we just made. For each different stages. After performing analysis, firstly, we can check the results, member forces or deformation for each different stage. So, if we want to check the summation, with the changes of the stages, we can check those results. Also, we can check the creep and shrinkage effects separately as well for each different stages. For the shrinkage effect, and after checking those data, as I show you during the presentation, there are another useful tool, which is group activation of construction stage. We can check all the activation or deactivation status in the table format at once for the element, boundary, and load. And finally, we can check the column shortening results. Go to the results and column shortening graphs. And then specify which column we want to check the results. For example, if we want to check the column, this column shortening, then check the coordination, and in the column shortening graph, click Add New Column. And then enter the coordinate. Since this is the concrete structure, so as I mentioned earlier, we only need to consider the post-installation slab shortening. So for this, we will only check the post-installation slab shortening, which is written as sub2 in the MidasGen. Okay. So data we just entered are displayed here. And let's check the... So we can check each different shortening for the creep, elastic shortening, shrinkage, and the total summation. This graph can be also saved as an image or text, or as well as the Microsoft Excel data. Okay, so that's all for the presentation that we prepared today. If you have any question for this construction stage analysis, please use your questions window. There is one question regarding the tendons, post-tension tendons. First of all, we have seen during the demonstration, for the post-tensions, we need to specify the type here as a post-tension and then enter the required data such as the tendon material and tendon area, duct diameter, so on. And then enter the coordinate of the tendon. And in order to activate during the construction stages, each different stages, if we go to we need to enter the tendon pre-stress load. Here we can specify different group. Then for each different stages, we can specify it as a group. So by changing it, we can consider each different stages activation. As we have seen in the stages dialog box, we can activate or deactivate them in these specific stages. The other question, if it's possible to use the wall element to enter in this position, which the load will be distributed to the transfer beam. We can use any type of the element. In order to show you the possibility that both are available, I entered two different elements here, two different element type here. So even though you enter the walls here, we can consider them as well during the construction stages. For the lateral load, there are another question if we can enter the lateral forces during the construction stages. Yes, we can consider the lateral loads as well. As entering them with the beam loads or nodal loads, we can activate or deactivate them during the stages. Only the live load or wind load or seismic load will be entered in the post stages. Another question regarding the difference between the plate element and wall element. As you can see in this picture, for the wall element here, we do not need to make the meshes in the one floor. So this wall can be used as a shear wall for the mid-rise or high-rise buildings. So it reduces your analysis and modeling time. But for the low-rise building, we recommend you to use the plate element. Okay, so I would like to finish today's webinar. If you have any further question, please send your question to our emails, esupport@midasuser.com. Then I can answer you for all your questions. Thank you very much for attending today's webinar.